So if you see the learning objectives, so here's some few things we should understand before understanding the optics of the contact lens or going through the optics of the contact lens. So first, I think the topic itself has a vast, means so many things are there. In lectures, I used to take many, almost 8-9 lectures to finish the optics of contact lens. But here, obviously, we have only 1 hour or 1.5 hour time. So I will try to finish it off within this time. And what we will discuss today about the vertex distance correction. I think all of you know who are from third year or intern or after who have already passed. Okay, so we're going to discuss about the vertex distance correction, then little bit of tear lens, astigmatism, magnification. This is very important, and the accommodation and convergence. What happens during accommodation and during convergence when we use the contact lenses. Next. Okay. So the next slide is the vertex distance correction. So I think those are from third year or already have passed optometry have gone through this formula, that power of contact lens equals to the power of spectacle by 1 minute DFSP. Here D stands for the vertex distance, and the vertex distance means all of us we know the distance between the back surface of the spectacle to the front surface of the cornea. So while we are wearing the contact lens, we should correct the vertex distance. And see, down it is written, it starts from 4 plus minus 4 diopter. So do you think it is compulsorily we should start from 4 plus minus 4 diopter? So it is not that we have to start from plus minus 4. So it is just like if you are starting from lesser than 4, means let's say 3.75 plus minus 3.75, obviously we'll get the result, but this is not a significant difference. So this is why we'll start from 4 plus minus 4. So we had heard about that when we correct the vertex distance for minus lens, the power will decrease, and when we'll correct for plus lens, the power will increase. So going to the reason behind it, we should understand few point or few certain things. I think in visual optics or optometric optics, all of you have heard about these things. Those are far point, near point. So so if we see the far point for the immotropes, these are infinity, and for hyperopes behind the eye, and for myopes it's in front of the eye. Okay. So here, what we do in correction of emmetropia. So while I'm mentioning the emmetropia, definitely I'm mentioning both or all, means myopia, hyperopia. So the correcting lens is that the lens which is the primary focus, it's very, very important. It is primary focus at far point of the unaccommodated emmetropic eye. So many times we forget to mention this one. It has to be unaccommodated emmetropic eye. So it's very easy to understand why it is decreasing during minus lens and why it is increasing during plus lens. So just think about the focal length. If you see this both picture, this is the first picture, this is the second picture. So if you see both diagrams, so just think about the focal length of the both lens, means plus lens and the minus lens, means the concave lens and the convex lens. So definitely, we use the concave lens when we are correcting the myopia, and we are using the convex lens when you are correcting the hyperopia. So what happens? So if we use the convex lens during hyperopia, so what happens during so the focal length will decrease when you are going from the spectacle to the contact lens. The focal length is decreasing. So if you remember the relation with the focal length with the power, it is the so if the focal length is decreasing, so the power will increase. The same for the myopia also. Here what is happening, the focal length is increasing. So when the focal length is increasing, means the power is decreasing. So if we use the formula FSP equals to FCL equals to FSP by 1 minus DFSP, I think today I'm not able to see you the derivation of this one, but this is the formula, and D is very important. This is the distance means the vertex distance in meter. So let's suppose you take the vertex distance of any spectacle lens, it's 14 mm in millimeter. So you have to convert this one into meter. Okay, so it's very easy to find out. So you can find out this one for astigmatic lenses also. So what you have to do, just you have to go through both the meridian. You have to correct the vertex distance for the 90-degree meridian or the 180-degree meridian. I rather must say the vertical meridian or the horizontal meridian, and then you can change the prescription for astigmatic lens. Okay. Then the next one is the tear lens, is the most important part of this lecture, the optics of the contact lens. So here, if you see the tear lens, what I'm talking about the tear lens is the tear meniscus. It lies between the contact lens and the cornea, between the contact lens and cornea. So while we are discussing for the soft contact lens, so we know the soft contact lens is contouring the shape of the cornea. The conformity is very good. So there will be very little or almost no tear lens between the cornea and the contact lens. So we should discuss about the rigid contact lens and the PMMA. So all of us, we know PMMA is not a RGP contact lens, it's a hard contact lens because the decay value, the oxygen permeability is 0. So RGP contact lens, and for the PMMA contact lens, PMMA material, these are tear lens is very important. Okay, so why it is important? Because so but tear lens actually can change little bit of prescription. Sometimes it can induce some prismatic effect also. Like how, if this image, if you see the image, I think the next image is more visible. If you see some fitting, when we go for some ULF fit, means underlid fit, when the upper lid is holding the contact lens, so you can see the tear between the tear lens between the contact lens and the cornea is acting like a prism, base down prism. So the base down prismatic effect will induce little bit. And also if you are going for the stiff fit or flat fit, so you are going for the steeper K or flatter K or on K also, then if you see this image, you can understand. If you are going for the flatter contact lens, the flatter fit where the center touch will be there, so we can induce little bit of minus concave lens. And while if you are going for the steeper contact lens or steeper fit, then we can induce some plus. So it is very easy to understand. So if you see the calculation, so it looks like little bit complicated, but it's not at all. Just look at the equation. Equation is written, the power F equals to n dash minus n by r. So here n dash is the refractive index of the substance, and the n is the refractive. So why we are going for this one? So here we are the assumption is the refractive index of the tear we are taking 1.336. The refractive index of the contact lens what we have taken, that is 1.490, and the refractive index of the air, all of us we know it is 1. And the refractive, so the radius of curvature we have taken here 7.8. So all those here the calculation will do behalf of this refractive the radius of curvature of cornea, that is 7.8. So now we will see how the power is actually changing. So here we have to understand why. So the front surface and the back surface, that we'll calculate the front surface and then we'll calculate the back surface. So we are calculating when we are calculating the front surface, the power of the front surface. So then we are writing, it is the formula we are writing, n dash minus n, means the refractive index of the substance minus the refractive index of the air by the radius of curvature of the cornea. Fine. So why we are writing for this one like this? Because we know how we write. We write like when the light is coming, all of us we know the light is, when we draw the ray diagram, it is coming from left side to the right side. So what we do, where the light is going minus from where the light is coming. So if we see where the light is going, if you take the first surface of the first surface, so the first surface where the light is going, light is going to the tear lens. So where the light is going, it is to the tear, minus from where the light is coming. So it is coming from the air. So the refractive index of the tear, all of us we know it is 1.33 according to the IACLE, and the refractive index of the air, all of us we know it is 1. So 1.33 minus 1 by, and it's very very important, the radius of curvature has given 7.8 in millimeter, but this formula is for the meters. We have to convert that one also in meters. So it has to be 0.0078, and the power we got 43.077. And then if we go for the back surface, now it is n minus n dash, means the refractive index of the air minus refractive index of the air. Now how it is happening? Again, where it is going, minus from where it is coming. Where it is going to the air, minus from where it is coming from the tear lens. Fine. So here if you see, here also it is coming 43.007. So what is this? This is the on K. When you are taking on K, so here we are getting value. The difference between this part is 0. So obviously we'll get a plano tear lens power. But what happens if we go little bit flatter? Little bit flatter means we have to increase the value of radius of curvature. So previously we had taken the radius of curvature of 7.8. So if you want to make flatter the contact lens, so what we have to do, we have to increase the value. So we are increasing the value from 7.8 to 7.85. Okay, here it is, one thing is very important. Here we are increasing the value at a rate of 0.05 mm. Means we are making it flatter at 0.05 mm, or we are making it steeper at 0.05 mm. This is why from 7.8 to 7.85. Now if you see here, same process is going on, and the first surface we are getting 42.803, the second surface we are getting 43.07. So here we are getting induce of little bit of I think almost approximately 0.25 diopter, minus 0.25 diopter. So minus 0.25 diopter is increasing while you are making the contact lens flatter for 0.05. Fine. What happens if you go steeper? Now if you are going for the steeper, what we have to do, you have to decrease the value of radius of curvature. So previously we had taken 7.8. what you have taken for this? We have taken 7.75. How much we have decreased? We have decreased 0.05 mm. Okay, so here what you have seen, after the calculation we have found little bit induced of plus 0.25 power. So if, for both you have seen, if you are going for the steeper contact lens or flatter contact lens, there is a induce of plus minus 0.5, almost approximately plus minus 0.25 diopter. Fine. So here what we can do, we can make a rule of thumb. So while the rule of thumb things are coming, so you should not be like, you should not buy heart those all things which there, everything you should understand and go through those calculations. And also I hope you understood how the calculation, how we are calculating this one, the rule of thumb. So the rule of thumb is, if you are flattening the contact lens curvature for 0.05 mm, there is a induce of minus 0.25 diopter. And if you are steepening the curvature for 0.05 mm, so obviously it will increase the power 0 plus 0.25. Fine. So this is the rule of thumb we have to understand. Sometime we will get confused that it will be the flattening and the steepening, it will be 0.5 or 0.05. So obviously it is 0.05 because we are going from 7.8 to 7.85. For an example, if you have 7.5 and you are going for if you have 7.5 and you are going for 8 mm, 7.5 mm to 8 mm, that is you are increasing the value from at 0.5 mm. But if you are going from 7.5 to 7.55, means you are increasing the value at 0.05. Fine. So this is the rule of thumb for tear lens, what you have to understand or we have to remember. So the next one. So the next one is one of the most important part of this tear lens, that while correcting the corneal astigmatism. So here we are discussing the corneal astigmatism, so not the total astigmatism. So if any patient is having the corneal astigmatism, 90% of the corneal astigmatism will be neutralized with the tear lens. So why it is 90% of the corneal astigmatism? Because if you see the refractive index of the cornea is 1.37, while the refractive index of the tear is 1.33. So we are inducing another separate lens with the tear, and that is not exact same as like cornea, the refractive index of the cornea. So why it is 90% only? Because if you see the calculation, if you see the difference between the refractive index of the tear and the refractive index of the cornea, so the right hand side it is given that, again it is given the calculation. So what we do, again the refractive index of the cornea minus the refractive index of the tear, because where it is going minus from where it is coming. So refractive index of the cornea is 1.37, refractive index of the tear is 1.33. Eventually we'll get 5.13, that is almost 10% of the corneal power. So this is why only 90% of the corneal astigmatism it will neutralize. Fine. So if anybody is having some lens astigmatism, so obviously we cannot neutral with the tear lens, then we can go for any other correction like toric RGP lenses or something. Okay. Now the most important, or one of the most important part, is the magnification. So here we have to discuss several magnification, mainly three magnification. One is spectacle magnification, contact lens magnification, and spectacle magnification, contact lens magnification, and relative spectacle magnification. So if you see the spectacle magnification, all these are actually comparison between one size of the image to the another side of the image. So the first one, if you see, is spectacle magnification, and the spectacle magnification we are saying it is the comparison between the corrected image size in ametropic patient with the uncorrected image size with the ametropic patient. Means we are talking about here the clear retinal image size, blur retinal image size. Fine. But if you see the contact lens magnification, that one is more realistic, because here we are comparing between the image size with the contact lens and the image size with the spectacle. This is what we should understand. Like when some patient is wearing spectacle, either the patient is myope or hyperope, then what should be the image size patient is seeing, and what is the image size with the spectacle and with the contact lens. Right? So here if you see the diagram, it's very easy to understand. So the image, the power correct height is directly proportional to the correction. But know this thing, that if you are going for plus lens, means the convex lens, so we'll get little bit of magnification, and if you are going for the minus lens, we'll get little bit of minification. Fine. So if you see the derivation, after the derivation, what will get the contact lens magnification? It is 1 minus d FSP. 1 minus d means here the vertex distance, and FSP means the power of the spectacle. Okay. So it is, if you see the contact lens show that myopes experience, so the hyperopes experience little bit smaller image with the contact lens than the spectacle, and in myope experience little bit of larger image. So obviously if you are going for the going for contact lens in myope, the patient will see little bit of larger image than the spectacle, and you are going for the hyperope, patient will see little bit of smaller image than the uh, spectacle. Now this one is actually, it is important. This is the relative spectacle magnification. Now what we are doing, here we have to relative spectacle magnification, the ratio of the image size in the corrected ametropic eye. Now here one thing you should understand, while we are discussing it is corrected ametropic eye, previously we have discussed the only for the myope or only for the hyperope. So what happens only for the myope, what is happening, the in spectacle lens the image size, the regular image size is a little bit, it will be a little bit smaller. In hyperopes it will be a little bit larger. In contact lens it will be, but here in relative spectacle magnification we are not differentiate myopia or hyperopia. We are talking about the ametropic eye, the image size at the ametropic eye. So we are comparing the image size of the ametropic eye with the normal emmetropic eye. Means if I am a normal patient, or means if I'm an emmetropic patient, if I'm saying any of the image, the size of the image, we are comparing that size of the image with the emmetropic eye, those who are myope or hyperope. Okay, so here we should understand to emmetropia or the refractive emmetropia, the origin, mainly the origin. So if you see the far point and the, so already I have discussed about the far point. Here in this image, the down image, if you see the below, so the spectacle plane. So if you see the spectacle plane, so if you keep the spectacle plane, the in case of refractive anisometropia, means in case of hyperopia, the image is, if you are wearing that, if the patient is wearing the spectacle, the image is magnifying. While in case of contact lens, here what is happening, the contact lens, this is the, I think that violet color. If you see the violet color arrow is the contact lens image. So contact lens image is little bit smaller, okay, than the spectacle image. But if you go for the myopia, for the refractive myopia, so now what is happening in case of refractive myopia, image is little bit smaller, but in case of this one, if you put the contact lens, if you see the violet color, the little bit it is larger than the actual image. So we can conclude. So okay, again, if you see the images, first one is for the hyperopia, when you are using the spectacle. So when you are using the spectacle, and this is the refractive hyperopia, you can see the image is in spectacle it is little bit larger, while in hyperopia, in axial hyperopia, in spectacle, the image is almost same how the image was with the without any means with emmetropia. But in case of refractive, it is different. The refractive, the image in myopia, the spectacle image is smaller, where the spectacle image in axial myopia, it is same. So what we can conclude for this, that in axial emmetropia, if anybody is having axial myopia or axial hyperopia, in that case it's better to correct. It's better to correct with spectacle because the image size is not changing that much. But if you come to the refractive emmetropia, it is better to correct with contact lens because here the image size is changing. Fine. So here again, if you see the relation between the relative spectacle magnification, the first one, the spectacle magnification compares the corrected with the uncorrected image, and the contact lens magnification, it compares with the contact lens image with the spectacle correction. And the relative spectacle magnification, this is the theoretical, the compares between the emmetropic image size with the axial or refractive hyperopia or myopia. So what happens if there is a aphakia? So aphakia comes under refractive origin. So obviously better if you go for the contact lens contact lens correction. What happens in astigmatism? Obviously astigmatism also comes in sometimes it's refractive emmetropia. So here what you can do, you can go for contact lens correction. So some spectacle lenses in higher astigmatism also can induce significant meridian anisoconia. So it's very better to go for contact lens corrections. Now, one of the most important part is accommodation and the convergence. Okay. So what we have to understand here about the accommodation and convergence, we should understand about the demand of accommodation, the demand of convergence. So while I'm talking about the demand of accommodation and the demand of convergence, so obviously I am discussing about how much a myopic patient want accommodation in contact lens and how much a hyperopic patient want accommodation or convergence in contact lens or in spectacle. Okay. So if you have all of you know about the accommodation, so just very small you know uh, about discussion about the accommodation, the difference between the vergence at the first principal point of the eye, that is the 1.1 mm behind the cornea between the ray of infinity and the rays at the near point. So what happens in contact lens, any myopia, in myopia patient is wearing contact lens, the demand of accommodation will increase, and anybody wearing hyperop, any hyperop wearing the contact lens, the demand of myopia will decrease. So here we are talking about the demand of myopia, how much a myope patient wearing contact lens will want contact lens accommodation. For them the demand will increase, and for hyperop the demand will decrease. So how it is happening? So let's take an example for the myopia. So if anybody is myopia, so what we do, so if you have a, let's suppose a metrope patient, so if you want to make a metrope patient a myope, so what we'll do, if you want to make 5 diopter myope, so what we'll do, you have to put a plus 5 diopter. So it's very easy to understand. So if you want to make somebody myope, so what we'll do, you'll put plus 5 diopter. Fine. So when you are using plus 5 diopter, so what exactly you are doing? So where you are increasing the power while patient is accommodating for the near. Fine. So already we have seen in vertex distance correction, while shifting from spectacle to contact lens in myopia patient, the power is decreasing in contact lens. Now what has happened? So previously, when the patient was wearing the spectacle, so patient already had more power for the near. So their accommodation, demand of accommodation was less in spectacle. But what happened when you have given the contact lens? So what you have done, you have decreased the value, decreased the strength of the power. So when you have decreased the strength of the power, obviously, now while patient will read with the contact lens, the myopia patient will read with the contact lens, they will feel little bit of less power while reading. So obviously that their demand of accommodation will increase. They will be having more demand of accommodation. Whereas in hyperope, so what happens? So again, the same example, if you want to make anybody hyperope, so what you will do, if we want to make plus 5 diopter hyperope, you will put minus 5 diopter in front of the eye. So what you are doing exactly? You are decreasing the power. Now while hyperope patient, so also we have seen, we used to see in the symptoms of myopia or hyperopia, if there is a hyperope patient, the main symptoms will be, obviously there will be difficulty to see at distance. Also there will be difficulty to see at near. Why it is like this? Because they have less power when they are accommodating and or they are doing some near work at this one while reading. So now what happened? So while you are shifting from the spectacle to contact lens, already we have discussed, when you have gone shifting from the spectacle to contact lens, so the power is increasing. The vertex distance, when you are correcting the vertex distance, the power is increasing in the contact lens. So now while the patient is wearing the contact lens, certainly they will get extra power for the reading. So obviously the demand of accommodation will be little bit lesser. Fine. So So here we can calculate the demand of accommodation. It's a very easy calculation. So the accommodative demand equals to the vergence of the near minus the vergence of the distance. This formula you can use. The accommodative need you can find by 1 minus the focal length, means the distance at the near distance what patient is using. So for an example, so okay, here if your patient is already using the contact lens, no need to correct the vertic distance, but patient is wearing the glass, you have to correct the vertic distance. So we'll take an example. If you see the example, what should be the accommodative demand if anybody is having minus 9 diopter and viewing for the 40 centimeter of distance. Okay, so it is for the contact lens it is 2.5 and for the glasses it is 1.5. How it is 2.5? So if you have seen the this is vergence of the near minus vergence of the infinity, means vergence of the distance. So vergence of the near, how you will find the accommodative need. So accommodative need, it has to be 1 by focal length. So focal length means the 40 centimeters. So we have to convert it into meter, because that 1 by focal length, 1 by f is for the meter. So here we will get 11.5 minus 9. 9 is the near vergence, and we'll get 2.5. But for the glass, we know if patient is wearing the glass, we have to correct the vertic distance. So this is how you can, you know, calculate the accommodative demand also. What about the convergence demand? So here it is written more in patient convergence, more in myope, with my more with myope in CL and less with hyperope in So it is very easy to understand if you see this image. So the first one for the concave lens and the second one for the convex lens. So we know if anybody is myope, we using the concave lens, and the prism prism is there in the concave lens is apex to apex, and in the convex lens it is base to base. Fine. So if it is apex to apex, now what is happening when the patient is looking at distance? So patient is looking at the so patient is looking at the optical center. Fine. So when patient looking at the near, so what they are doing, they're converging their eye. While they're converging their eye, they're no longer looking at the optical center of the spectacle lens. They're coming little bit, nasally. Their eyeball is coming little bit nasally. While this coming little bit nasally, so obviously for the first one you can see there is a induced of base in prism, okay. So where it is coming inducement of little bit base in prism, so where it is coming base in prism, so obviously the image will shift towards the apex. So when it is shifting towards the apex, so just think, so your eyes were here, okay, at this apex. Now what you think, it is moving towards the base. So when it is moving towards the base and the image is moving towards the apex, so you're coming this way and your image is coming this way. Fine. So when it is same, so both are coming at the same way, so obviously it will be easy for the patient to find the image easily. Fine. But while patient is using a spectacle of convex lens, their prism is base to base. Now when the prism is base to base, now you are you're coming for the near work, and your eyeball is coming nasally. Where the eyeball is coming nasally, the prism inducement will be base, base out. So when it is base out, so you can understand the image will shift towards the apex. So the image is shifting towards the apex, means towards nasally, and your eye also shifting towards nasally. So when it is shifting towards nasally, means both are shifting at a same direction. So when it is going at same direction, obviously you can understand it will be very difficult to find the image, whereas in the myopia, in the concave lens, it is very easy to find, because both are going in the opposite direction. Okay, so just like a thief, if you're running behind the thief, it will be very difficult to catch the thief. But if you're if the thief is running towards you, you can easily hold the thief. Fine. But what happens in the contact lens? Now, if anybody is wearing the spectacle and shifting to the contact lens, so let's suppose first for the myopia. So the myopia, what was happening for the myopia when the patient was wearing the spectacle, for them, the need of convergence was less, because easily they were finding the, because of the prismatic effect, because easily they were finding the image. But while they were shifting to the contact lens, now while you are asking the patient to read the near letter, now they may complain of little bit of blur or not uneasiness while reading. Why? Because previously it was very easy for them to find the letters, but now while they are using the contact lens, now there is no prismatic effect and the patient can easily will not find easily those images. Okay, but whereas in hyperope patient, now what happens, previously for the patient it was very difficult, because the images and the eyeball was going at the same direction. But now what happens, there is no prismatic effect, so little bit they will move their eye when the patient is wearing the contact lens, little bit they will move their eye and they will find the image when they are wearing the contact lens. For them it will be very easy. So this is why when patient is wearing the contact lens, any myopic patient is wearing the contact lens, the demand of convergence will be little bit more. But where the patient is wearing the contact lens in hyperopia, the demand of convergence will be little bit less. So how you can find out the this one prismatic effect? All of you know the Prentice rule. It is the prismatic effect equals to CF. C is the decentration and the F is the power. And this formula has you know has mentioned for centimeter, very important. Okay, this is the image for the previous what I have discussed. So if you are using for the first, the left hand side is patient is using the spectacle, and the right hand side the patient is using the contact lens. So if you see the patient is wearing the spectacle, convex lens, so here because patient is going for the near work and there is a base in prism inducement, and the patient the image is moving towards the apex, and for the other one means for the minus lens, the the image is moving towards temporary. Fine. So what is the optical advantage and optical disadvantage of the? So first advantage, if you see, there is no astigmatism of oblique pencils, no distortion, very important. Obviously no chromatic aberration, no limitation of the field of view, all of you know about that, and spectacle diplopia is not there. But if you see some disadvantages, optical disadvantages of the contact lenses, so here the lens decentration may, if you have the lens decentration, may produce little bit of ghost images. So if you have the toric lens, you have to be very careful about the rotation, toric rotation, and moving the lenses may produce little bit of disturbance of vision. So means moving of lenses means if you're fitting some contact lens, and if you fit any flat contact lens, a little bit more flatter contact lenses, and axial emmetropia, all of you have seen, if there is a axial emmetropia in contact lens, what is happening, the size of the image size of the image size in contact lens, it is if there is a myopia, it is increasing more, and it is hyperope, it is decreasing more. So it is better in spectacle, because if you see the if you are comparing the relative spectacle magnification, means if you are comparing axial emmetropia with the image patient, so the image size is almost same. While the image size is almost same in the spectacle, so it's obviously better to go with spectacle rather than going for the contact lens. But if you're having the refractive corrections, so it's better to go for the contact lenses. So in refractive correction, obviously you have phakia also, and astigmatism also. Okay, so with this one, I hope all of you have got little bit of idea about the optics of the contact lens. And I want to conclude my this PPT. And thank you so much to everybody join. Anybody has any query or any question?
Thank you, sir, for your very informative presentation. Now I would like to open the chat box for the question. In case if everyone has any doubt, you can ask them in chat box. I will read it to the sir.
I have one question written in the chat box. Please look at the.
Okay, yeah. So, I think Himanshu have asked about the axial myopia and the axial hyperopia. Okay, so actually, this topic, I think it is really tough or really difficult to explain without drawing the image. Because what I used to do is to draw the image in the board and
Actually,
description.
sir.
So it is just like, so it is very easy to understand. So if you have the axial emetropia, so what
Right, right.
happens in the axial emetropia? What happens in the axial emetropia? So here we are discussing about the axial length, the increasing, the decreasing
Exactly.
of the axial length. Okay, fine.
Exactly.
So here, here if you comparing the relative spectacle magnification with the spectacle and the contact lens, we are comparing with the patient, the image of emmetropic patient. Okay, so here what we have seen, that the patient using the spectacle, the image size of the spectacle is almost same, equal to the image size of the uh,
Contact lens.
not contact lens, image size of the emmetrope patient. Okay, while if
Okay.
you are seeing the contact lens, now what is happening in the contact lens? In contact lens, let's suppose myopia, anybody is myope patient is using contact lens in axial myopia. Okay, fine. So
Right,
myopia, so
right.
what happens myopia, we use the the concave lens. So concave lens induce minification. Fine. So
Okay.
normally what happens, minification, so minification means if you have a certain image, so it will minify in concave lens. So what happens in the concave lens, uh, if you are using the contact lens, it should magnify this one in contact lens in myopia. But what is
Right.
happening while you are using the contact lens, it is magnifying more, little bit more, or it should not be, the actual image you are seeing, you want to see like how the emmetrope patient is seeing, while you are seeing the spectacle users are using or seeing the better image than the contact lens image. So this is why I think it is better to go for the excel. So there is no hard and fast rule that you, for this much, this one you have to go for spectacle, or this much you have to go for the contact lens. It's all about the strength of myopia or the strength of hyperopia. And if you see the all
Okay.
researches, all those things, the high myopia, in if there is a high myopia or high hyperopia, almost all are, refractive corrections. So obviously in refractive correction you will go for the, it's better to go for contact lenses only.
Sir, maybe the reason we cannot change the axial length. That's why with the reason. That's
Yeah,
why with
yeah,
the reason.
you cannot. Yeah, you can, if your height is
Axial
going,
myopia,
it is
hyperopia.
increasing, you cannot, either you can cut yourself, you cannot do anything. There is no medicine or something that you can decrease the height or increase the height.
Exactly, sir. Exactly. Thank you, sir.
Anything else?
Sir,
Uh,
ortho
I
K
yeah,
we
yeah,
can give in
fine,
Excel.
fine. Yeah, fine. Ranjana, yeah, I can. And I think the presentation, I have taken the almost all slides from the IACLE. So if you have the IACLE PPT, I know the recent IACLE PPT, the new IACLE PPT, this is the same IACLE slide that I just copied and pasted. And with the, I've asked the IACLE members if I can. So because I am the IACLE educator, so I can use this one. So if you have, if you don't have, I can share the PPT. If the tear lens is induced power. Okay, Uma Maheshwari is asking, if there is tear induced power, what should we add? Okay, okay. So so it depends on how much you are increasing and how much. So I hope you remember the what is this rule of thumb. So what has said the rule of thumb? So it is just like if you are increasing the value,
0.0.
I'm talking about the radius of curvature. Okay, so it's very important to the understanding the radius of curvature in the diopter. Fine. So I am discussing the radius of curvature. So if you are increasing the radius of curvature, means radius of curvature. So the value of radius of curvature means what we are doing, actually we are flattening the lens. So we are inducing the radius of curvature of 0.05 mm. Fine. So while you are increasing the radius of curvature of 0.05 mm, so I have shown you the calculation that there will be an increase of power or minus 0.25, approximately minus 0.25. Fine. So then you can change according to that. If you are changing, if you are steepening at 0.5, sorry 0.05, so there will be inducement of, I think, plus 0.25, approximately 0.25. So according to that, you can change the power also. Yeah, I can. I think I will send to I think Satyam or anybody this PPT. I'll mail to this PPT. So I think others can, if you want, you can contact with Satyam. Okay.
This
Okay.
is
Fine.
all from the modules from the IACLE module. All the PPTs
Yeah,
make
IACLE
up from
module.
the IACLE
Yes.
module.
IACLE module. And the recent IACLE module. The recent one. I think the third IACLE module. Yeah, I got another question. Smriti, why presbyopia myo have problem with contact lens? Okay, that just what we have discussed now. Because if there is a myo, so what happens during myopia? So obviously they will be having a little bit of extra power for the accommodation. Why there will be extra power? Because if myopia means they'll be having the extra accommodative power. Already they will be having the extra accommodative power. So if you are giving a contact lens, not with the contact lens only, maybe with the spectacle also while reading, so they always tends to remove their spectacle, or if there is a contact lens, because if you are giving that contact lens, if you are correcting this one, the near power, so they are not getting that extra power already what they were getting. So just an example, if same example, if you want to make anybody myope, if you want to make any imetrope myope, what you do, you have to plus 5 diopter, minus 5 diopter myope, so you will put plus 5 diopter. So already they are having extra power, for the reading. So if you going for the correction, so they are not having those extra power. So obviously they will be having those extra, will be having the problem while reading. So this is why they will be they tends to remove their correction while reading.
Any more queries? I think this is it. So finally, I would like to thank you, sir, for taking over such an informative presentation. And also I want to thank everyone who have attended this session. We hope every one of you have found this session informative and valuable.